Okay, this is a tutorial video on how to calculate molarity questions. You need to be familiar with the formula, either written in words or in letters. Molarity is equal to moles divided by liters. It cannot be in grams, it must be in moles. Or moles is represented with the letter N. Capital M is molarity, N is moles, capital L for liters. If we take the sample, so like take a pinch, measure that in grams, if we divide by molar mass, which is in grams, then that will tell us how many moles of whatever substance we have. Let's try a few questions. Make sure you have your calculator handy. And on my website, I've posted a copy of the periodic table we use in class. I'll be giving you the information you need for this video and showing you very quickly on the periodic table where to find it. But having your own is far better. In our in our formula chart, here's the formula for molarity. Okay, so let's do this one. In lab, 3.50 liters of water is mixed with 0.28 moles of sodium chloride. What is the resulting solution's molarity? Okay, so notice that we have our volume written right here. Okay, so volume is 3.50 liters. We know that we have 0.28 moles. MOL for moles, M is meters, do not change it. And we know it's sodium chloride, which is just like the active ingredient in your toothpaste. Okay, so what is the resulting molarity? So molarity is what we're looking for. Okay, we know our formula is molarity is moles over liters. I'll go ahead and use the abbreviated so it'll go faster. Okay, and so molarity equals, we don't know molarity, it's equal to 0.28 moles divided by 3.50 liters. And in our calculator, if we take 0.28 divide by 3.50, we'll get 0.08. So we have 0.08 molar solution made here. I don't mind if you don't label it sodium chloride. Okay, let's do another one. Now, I'm going to flip back and forth as we need these. For right now, let's do this. Okay, then I know it'll be in the camera frame. Alright, so we have 47.2 grams of KCl mixed with 1.50 liters of water. What is the molarity of the solution that's made? Okay, so we see we have grams and we don't like that. We need moles. So first thing is we have to change our grams to moles. It is KCl, so I'm writing KCl in our work. Okay, the given's always over 1, just 1 to start with. Okay, KCl. I know that potassium, group 1 is right here, 39.098, and chlorine, 35.453. So K at 39.098, Cl 35.453. So if we notice 1 and 1, add them together. Okay, so 35.453 plus 39.098 equals, do not round it, I'm not rounding it either, we get 74.551. 74.551. Okay, there's the molar mass, 74.551. Okay, that's how many grams make 1 mole of the potassium chloride. So if we take the 47.2 and divide by 74.551, okay, equals, it says 0.6331, so we know that's 0.6331. The one, actually we can just erase that and make it moles, because the 1 will not make the 3 round up. Okay? All right, now let's see if we can find the molarity of the solution. Okay, we know molarity is equal to moles per liter. Okay, so we need to say, how many moles was that? We knew it was 0.633. Okay, 0.633 moles divided by, okay, it says 1.50 liters in the question. So, here's where I got my liters from. 0.633 divided by 1.50. 0.633 divided by 0.50 equals 0.422. 0.422. Capital M for molarity. Okay, write it correctly. So MOLs for moles, capital M molarity. You can see why we just cannot pick any old label we want. They already have different meanings. Okay, let's do another question. Okay, this time we're going to solve for volume as well as how many moles. This one has 425 milliliters of water mixed with 90 grams of sodium fluoride. Okay, what's the resulting molarity? Now, we're not allowed to use milliliters. It has to be in liters. So we'll take our 425 milliliters. Okay, we'll divide by 1,000 because 1,000 milliliters make a liter, and that will give you 0.425 liters. Now that it's in liters, we can use the volume, but we could not use it as milliliters. That would not work. Okay, let's continue. If we have 90 grams of sodium fluoride, okay, sodium fluoride, there's one N and one F, okay, N is 22.990 on the periodic table, while fluorine is 18.998. Okay, again, there's one Na and one F, so times 1 on each one. And so we get, clear, okay, 22.990 plus 18.998 equals 41.988. 41.988. Okay, now that's the molar mass of NaF. Okay, so if we take our 90 grams and we put grams, which was molar mass, in our denominator here. Okay, 1 goes there. Okay, well that's the amount of grams makes 1 mole. So 90 divided by 41.988, we get 2.143, which is 2.14 moles. Okay, let's plug that all in. 2.14 moles divided by 0.425 liters. 2.14 divided by 0.425 liters, and we get 5.035 or 5.04 molar solution. We say molar when we use it like an adjective. 5.04 molar solution, and there's our response. Okay, I have a few more examples. Let's try those out. Okay, I repeated the reminder that we divide by molar mass to get how many moles, and if we divide by 1,000 we can get milliliters. Okay, how many moles of HCl are in 575 milliliters of of 1.5 molar solution of HCl. Okay. All right, so we have it in milliliters once again, and you'll get really quick at changing milliliters to liters. You just divide by 1,000, which really, when you divide by 1,000, you're just moving the decimal point 3 times. So the 575, here's the old decimal point. 1, 2, 3, here's your new decimal point. So when you divide by 1,000, there's your liters. I like to move the decimal point really. I just move it 3 times, once for each zero. I'm sure it was my 4th grade teacher that taught us how to do that whenever I was in school. But anyway, 0.575 liters. Oh, that's almost not readable now. Okay, 0.575 liters. There, gotta have it right. Okay, we already have it in molarity, because we're not looking for molarity this time. This time we're looking for how many moles. Okay, so we'll set up our molarity number equal to moles, which you don't know, N, divided by our volume, 0.575. Okay, now anytime I have a number equal to a fraction, I put the number over 1, and I know I have to cross multiply. Okay, when I cross multiply, I do 1.5 times 0.575. That's what I do here this time. So 1.5 times 0.575. So molarity multiplied by volume is what we're really doing, equals, and you actually get your moles because N times 1, so 0.8625. 0.8625. Now that 5 makes the 2 go up, so 0.863 moles, because moles, remember, is what we were looking for. And there's the answer to that question. And I have one left. We have what is the volume this time, and what volume of water must be used to make a 1.75 molar solution. Oh, we have grams again, 238 grams of CaCl2. Okay, so Ca is 40.078 on the periodic table. Cl is 35.453. Notice this time we have CaCl2, so that one's multiplied by 2. If I add that up, I'll get the molar mass. Okay, so 40.078 plus 35.453 times 2 equals, and the calculator says 110.984. Okay, there's the molar mass, grams per moles, there's the molar mass of CaCl2. Okay, so if we know that, let me rewrite this first part, not worry about it here. 1.75 molar is equal to how many moles? Oh, we still have to find that. Okay, so 238 grams. Okay, well, grams goes down here. 1 mole, we want to convert it to moles. Okay, the 110.984 goes here. Make sure 4 looks like a 4 and not a 9. Make sure 9s don't look like 4s. Okay, 238 divided by 110.984. Remember, don't round those. I don't either. I stick them straight off the periodic table. Okay, 2.1444. Okay, so that's 2.14 moles. The 4 is followed by 4, so I'm going to leave it as a 4. It does not get to round up. Okay, so we now know 2.14 moles. We can find our volume in how many liters, really. How many liters is our volume? Okay, well, let's do what we've got to do. We need to cross multiply. Okay. There will be a 1 under here. We'll cross multiply. That gives us 1.75 times L or V, whatever letter you want to use. I tried to use L actually because it's L for liters. And then 2.14 moles. I'm just going to put 2.14. That's multiplied by 1, which is just 2.14. But I want L by itself. Right now we've got 1.75 times L. So to opposite of multiply is divide. So if I divide by 1.75, I can get the L alone. Divide by 1.75 on both sides. Okay, this will cancel. So 2.14 divided by 1.75. Okay, 2.14 divided by 1.75 equals, and you get 1.2222. Okay, so 1.22 liters. And there is our volume. Okay, I hope you find this video helpful. Have a good day.